Hey guys, and welcome back. In this video, we're going to get our player characters moving around in our game world. So I'll go ahead and create a brand new C# script called player controller. Once that's been done, we can add this script onto our player character prefab. In here, we'll basically create a simple player controller script. So I'll start off by creating a public float variable for the speed. Then inside of the update function, we'll create a vector2 variable called moveInput. That will be equal to a new vector2 with the x coordinates being input.getAxis raw horizontal and the y coordinates being input.getAxis raw vertical. So we're basically storing the arrow key input of the player. Then we'll make another vector2 variable called this time moveAmount, and that will be equal to our normalized moveInput multiplied with our speed variable and multiplied with time.delta time. So for you who don't know, we need to normalize our input vector or else the player will move faster when going in a diagonal direction. And then we're also multiplying with time.delta time to make the movement frame rate independent. In other words, it ensures that our player character will move at the same speed on a new fast PC or on an old slow one. With that done, we can now actually move the player by adding to his transform.position or moveAmount vector. So to quickly recap, we just made a very simple player controller script. First of all, we're just detecting the arrow key input of the player's keyboard in this moveInput vector. From there, we're calculating the moveAmount vector, and finally, we're applying that vector to our position to actually move our player character. So this script would work perfectly fine in a single player game. However, for a multiplayer game, there is one small problem. If one player hits the left arrow key to move left, for example, every single player character in the room will also move left. So we need some way of knowing if this instance of the player character is the local player. In other words, the character that you spawned in when you entered in the game scene. We can easily do so by first of all adding the photon.pun namespace. Once that is done, we'll make a photon view variable that I'll call view, and we'll set it equal in the start function to the photon view component that is attached to the player character. If you don't remember, the photon view component is the component that we added to our player character in the last video that enables him to get spawned on the network. Then before running these 3 lines of code in the update function, we'll first of all check if view.isMine is equal to true. In other words, if this player is R1, the one that we should be controlling. If this is true, then these lines of code will run and so our player character will move. But if not, then this player will not get affected. Alright, with that done, we can now save the script and go back to Unity. The last step that we need to do to make this all work is to make the movement sync. This way, everyone can see the character move and not just the player controlling it. We can do so very easily by just adding the photon transform view classic component to our player character prefab. Once it has been added, just check this box to synchronize the position. Leave the other ones unchecked since we don't need to synchronize the rotation or the scale of the player character. Okay, we're done. So as always, we will go ahead and build our game by pressing Ctrl B or Command B if you're on a Mac. Alright, so once both instances of the game connect to the server and join the same room, you'll see that I can move the player character on this build of the game and his position gets beautifully synchronized on the other instance of the game. So to recap how to get multiplayer movements working, we first of all build a classic player controller script. Then, thanks to the photon view components, we're able to only run the movement codes if the player is the local player. In other words, the player that got instantiated when we arrived in the game scene. And finally, we added the photon transform view classic component to the player character to synchronize his position so that every player in the room can see him moving. And that's it. You are really doing some amazing work here, so keep it up and soon you'll have your first multiplayer game to add to your portfolio. Of course. In this video, we'll add some animations to our player character to make him look more alive. You'll see that the process of doing this for a multiplayer game is almost identical as for a single player game. So in between videos, we just went ahead and created 2 simple animations. An idle animation for when our player will not be moving, and a run animation that we want to play when he is moving. The first thing that we need to do is to add a animator component to our player character prefab. With that done, I'll now go inside of my animations folder and I'll create a new animator controller that I'll call player AC for animator controller. Once it's been created, you can drag and drop it inside of the controller slot on the animator component that we just added to our player. Now let's go ahead and open up our player animator controller. In here, we'll drag and drop our new animations. Make sure that the idle animation is the default one that gets played at the start of the game by right clicking on it and choosing set as layer default states. Let's now click on this little plus sign up here and create a bool parameter called isRunning. This bool parameter is what we'll be setting to true or false in our player controller script to let the animator controller know what animation he should be playing. Now let's create a transition from the idle animation to the run animation by right clicking on idle, choosing make transition and then clicking on the run animation. If you now select it, we can set the condition to be isRunning true. This means that we'll transition from playing the idle animation to the run animation if isRunning is equal to true. We'll also uncheck has exit time and set the transition duration to 0 so that the transition happens instantly and feels nice and responsive. Likewise, we'll create a transition from the run animation back to the idle animation. This time the condition will be isRunning false. And of course, we'll uncheck has exit time and set the transition duration to 0. Okay, so with all that set up, we can open up the player controller scripts. In here, we'll create a animator variable called anim. Then inside of the start function, we'll set it to be equal to the animator component that is attached to this player character. Then we'll go right underneath the code that moves our player character. Remember that this code is wrapped in an if statement that makes sure that we are the local player, in other words, the player that we spawned in at the start of the game. So here we'll make an if statement that checks if move input is equal to vector2.0. In other words, if there is no input from the player and so no movements. If this is the case, then we'll set the animator's isMoving bool parameter to false with this line of codes. Else, so if there is input and so we are moving, then we'll set isMoving to true. So to quickly recap, we're just checking if our move input is equal to vector2.0, so if there is no keyboard inputs. If that is the case, then we are setting isMoving to false. Otherwise, if move input is not equal to vector2.0, so if there is some sort of keyboard inputs, then we are setting isMoving to true. And that's it, so we can now save the script and head over back to Unity. If we just leave things as they are, it would work perfectly for a single player game. However, for a multiplayer game, only the local player will see his animations change, but the other players will not. So to synchronize these animation transitions over the network, we'll add to our player character the animator view component. On this component, you'll see our isRunning parameter. All we need to do is to make sure to set the synchronization to discrete and we'll be all good to go. So let's build our game by pressing Ctrl B or Command B if you're on the Mac. And like promised, our animations are working perfectly and they're getting seamlessly synced over the network. Our player character now feels much nicer to control. Congrats for completing this tutorial and for already getting this far in the course. You're making some great